So, in the last few lectures we talked about magnetic moments of current loops and also motion of charged particle in magnetic field and crossed EP field. So, today we will be solving some problems based on these topics. So, our first question is this: a particle of mass 30 microgram with a charge 10 nano coulomb moves in a magnetic field B equal to 1.5 Tesla in k cap direction. At t equal to 0 it was at the origin and its velocity was 5 root 2 centimeter per second I cap plus j cap plus k cap. Then the question is, find the maximum distance of the particle from the z axis during the motion and find the velocity at t equal to pi by 2 seconds. So, let us see what it is. The magnetic field is in z direction and initial velocity has all three components I cap, j cap and k cap. So, it has a component parallel to the magnetic field and other part which is perpendicular to the magnetic field. So, because of the part which is along the magnetic field, this velocity will remain constant and the particle will go up in z direction, but because of this perpendicular component perpendicular to the magnetic field, it will in xy plane it will go in circle. So, that is it. And if this is z axis, that means the path will be something like this, it will spiral, every time it is going up. At any point its velocity has a z component and that z component is given by this 5 root 2 centimeter per second. That is the z component with which it is going up. Then the perpendicular velocity which is taking it in xy plane, in circle in xy plane, that is in xy plane, that is 5 root 2. We will do the work in centimeters and second. So, I am writing only 5 root 2 I cap plus j cap. So, the magnitude of this velocity will be 5 root 2 and times root 2, because this vector I cap plus j cap has magnitude root 2. The x component is 1, the y component is 1, and therefore, the magnitude will be 1 square plus 1 square square root. So, this will be the magnitude and this is 10 centimeter per second, all lengths in centimeter and time in second. Now, with this velocity, if it is projected perpendicular to the magnetic field, that means perpendicular to this z axis, then it will go in a circle, in xy plane it will go in a circle, and the radius of the circle will be the radius of the circle in xy plane, that will be given by mv by qb, So, that is the kind, and remember is this picture is not very good. The particle is projected from the origin. So, the origin is here and therefore, the z axis is like this, So, the diameter of this circle will be the maximum distance from the z axis. At t equal to 0, it is on the z axis because it is at the origin, it is given at the origin, it is on the z axis, and then there is a speed and then it will turn and make a circle and again will come back at same point in xy plane. So, this is it. So, if you calculate this r, how much is this r? M mass of the particle is 30 micrograms. So, 30 micrograms. So, we are taking mass in grams and then this length in centimeter. If I do not write the unit, you assume that it is this, and time is in seconds, into V. V is 10, V is 10 centimeter per second, and then divided by Q. Q is given, the charge is given 10 nano coulomb. So, it is 10 nano coulombs. So, 10 power minus 9 and coulomb. So, the charge is in coulomb. And then you have B. B is 1.5 Tesla. So, into 1.5 Tesla. All right. If you convert it in SI units, then what other things you have to do? This is in grams. So, kg 10 power minus 3. Now, it is in kg, and then this 10 is 10 centimeters per second. So, centimeter will be 10 power minus 2 meters per second. So, this was converted. This is 10 nano coulombs already SI, and then 1.5 Tesla already SI. So, these many meters, these many meters. So, you can work out how much it is. It is 1.5 here and 3 here. So, that is 2, and remaining is all 10. So, 1 power from here, minus 6 is from here, 1 power from here, and minus 5 power from here, and then this is 10 power minus 8. So, plus 8 here. So, these many meters. So, that is 2 into 10 power. How much is the power? Plus 1, 2, 10, and minus 6 and minus 11. So, in plus you have 10 and in minus you have 11. So, these many meters. So, this is 2 into 10 power minus 1 meter, that is 20 centimeters. And therefore, the maximum distance from the z axis is 40 centimeters. Right. So, that is our question 1. Now, let us move to question 2. So, an electron is emitted with a negligible speed from the negative plate of a parallel plate capacitor with large plates charged to a potential difference V. So, you have a parallel plate capacitor and charged to a potential difference V. So, let us say this plate is at 0 and this plate is at potential V. So, this is the negative plate and this is the positive plate, and an electron starts from this negative plate with a negligible speed. So, it starts from here and its speed is negligible. Then the separation between the plates is d. So, the separation between the plates is d, and a magnetic field B exists in the space in a direction parallel to the plates. So, here are the plates and parallel to that a magnetic field exists. So, we take this coming out as the magnetic field, and therefore, we draw this figure for B. So, magnetic field exists parallel to the plates. Now, show that the electron will fail to strike the upper plate. This electron will fail to strike the upper plate if this condition is satisfied, if the magnetic field is strong enough and B square is greater than 2 times mass of electron times V divided by ED square. So, that is the question. So, if I draw the axis and take this direction as the x axis, this direction as the y axis, this is V here and this is 0 here. So, the electric field is in the negative y direction. So, E is equal to E times and then minus j cap. Then you have B. B is equal to what? B is coming this side. So, it is B times k cap. So, if I try to analyze here, initially the velocity is 0 and the electric field is in the negative direction. So, the force on the electron will be in positive direction. So, the electron will start this way, and once it starts this way, it will bend. You have a magnetic field coming out, velocity is in this direction. So, V cross B is in towards this side, and since it is negative charge, then it will turn and then go in some path. So, get that path, we go for our standard method. We will look at the electron, look at the situation from another frame S prime in which this electric field should vanish. This electric field should vanish. So, if I write the force here, the force is Q times E and plus V cross B. And this V, if I take a frame S prime, which is moving in this lap frame at certain velocity, which is V naught equal to E by B. The force here in Galilean transformation, the forces do not change. So, this is from S prime frame. And in this frame, if I write this force on a charged particle, then it will be equal to the same force Q times E plus V cross B. Okay. And then we have this equation that this velocity can be written as V prime. This V prime in this frame will be V in the original frame and minus V naught. So, from this frame, if I am seeing the velocity, then you have to subtract this velocity V naught. So, we are subtracting to get the velocity in this S prime frame, and therefore, this V can be written as V prime and plus V naught and then cross of B. So, this is equal to Q times this E here and plus this V prime vector cross B vector, and then you have plus this V naught, let us write V naught here, V naught cross B and then plus V prime cross B. This E is what? This E is E in minus j direction. So, E is E naught and in minus j direction. V naught is equal to E by B in I cap direction, and then B is in k cap direction. So, let us calculate this quantity. What is this? This is E naught times minus j cap and plus V naught is E by B. So, it is E by B here, this is E by B here, and then I cap here. So, that is I cap here, and cross product with B. So, B and k cap. So, what we see is it is not cancelling, it is adding. This plus B cancels out and E and then again minus j cap. So, we should take this S prime moving in this opposite direction, in this direction with this same speed. In that case, this V naught will be minus of this and then correspondingly here if I write, then this is minus, and then this minus with this minus will make it plus, and then this will be 0. So, in this particular frame S prime, this F vector is, this force vector is only q v prime cross b. This one q v naught we have written here. So, this is v prime. So, v prime cross b. That tells me, since the force is only depending on magnetic field for whatever velocity or whatever charge or whatever, therefore, the electric field here is 0, and you only have magnetic field that is in k cap direction. In this particular frame S prime, in this S prime frame, we do not have any electric field, we only have magnetic field, and that magnetic field is coming out of the board. This is still the x axis, x prime axis, and this is y prime axis, and the magnetic field is coming out of the board. The particle is here, the electron is here, and this electron now moves in the positive x direction. In lap frame, the electron was at rest at the origin to start with at t equal to 0, and that same t equal to 0 if I see from this S prime frame, then this electron is coming towards positive x axis, and therefore, the electron is coming this way. So, what is the direction of force? What is the direction of force? This is the velocity of the electron as seen from here. Here is the magnetic field. So, if we have V and then cross B, so V and cross B is downward, but then its negative charge. So, the force will be in upward direction in this frame. Okay. So, you can write here the velocity is V naught I cap, this is the velocity, and the magnetic field is B k cap, and therefore, the force it is minus E times V cross B. So, V naught B into I cap cross k cap, and this is minus j cap, and here is this. So, this is in j cap direction, this is in j cap direction. So, that means in the positive, this it will bend in this direction, and it will go in a circle, it will go in a circle, because you do not have any electric field, and the initial velocity is perpendicular to the magnetic field, and therefore, it will go in a circle. What is the radius of this circle? Radius of this circle is R equal to mv by qb. This is the equation. So, m is mass of electron, and v, the speed does not change, there is no electric field. So, whatever is the speed at t equal to 0, that same will be the speed after the motion starts and throughout the motion, and that is this v 0. So, this is it, which is E by B. We can write it E by B, then divided by charge is electron. We have already seen the direction. So, now we are writing the radius. So, we have to write only the magnitude and one more B here. So, this is m E times E, which is V by D in fact. This is m E, this E is V by D, then B here, and then this B here, and the charge here. So, that is the radius, and the diameter is double of this. The diameter is double of this, 2 times m E times V, and then divided by E d B square. Now, in this frame itself we can see, if this is your lower plate also, your lower plate is here, this is the origin. So, your lower plate is here. So, this is the lower plate, and the upper plate is somewhere, upper plate is somewhere, this is that upper plate. Now, if it will fail to strike the plate, upper plate, if this diameter of the circle is smaller than d. This is d. Okay. If this diameter of the circle, this diameter is smaller than the separation d, then it will fail to strike. So, this diameter 2 m e v by e d b square, this should be smaller than small d, right. So, I can take this b square here and the d can come here. So, it tells me that 2 m e v divided by this d comes here. So, e and then d square and this b square that will go there, this b square will go there. So, this is the condition, and you can write in the other way also, b square is greater than this. So, b square is greater than 2 times m e v by e d square. So, if this is the condition which is given here, b square greater than 2 m v by e d square, if this is the condition, b is so strong, then it will bend it below this upper plate, and hence this is the condition. Now, in S prime, if it fails, then in lab also it fails. If it strikes, it strikes, that event is there. If it strikes, that has to be seen from the lab also. So, it fails in this frame, it is same as it fails in this frame. Here it will not be circle, but whatever will be the path, it will fail to strike here if this condition is obtained. Next question, wire loop ABCDA, this wire loop ABCDA carries a current I. So, it carries a current I as suggested in the figure. ABC, this is a semicircle. Remember, it is a 3-dimensional figure, YZ is in the plane of the board, X is coming out. So, you have a semicircle of this kind, a semicircle of this kind. This B point is somewhere here, somewhere here. So, ABC is a semicircle of radius capital R. So, this is radius capital R in the xy plane, and CDA, the other part, is a semicircle of radius of small a in the yz plane, in the y. So, this I could have drawn a good semicircle because it is in yz plane. Calculate the magnetic dipole moment of the loop. So, here you can work out, you can consider this line as having a current towards right and also current towards left. So, there is no current. In this you can think this wire, which is it is not a wire here, the wire is here only. So, you can mentally join these 2 points, make a current here, current going from left to right and also from right to left, so that the total current is 0 and does not make any difference. So, if you look for this loop, this closed loop, this is a closed loop, but then it has 2 parts, and one part you can say that it is A B C A, and then the other part is this C D A C, and you can write the magnetic moments of the 2 parts and then add. So, if you look for this ABC part, ABC, this loop A, B, C and this current, So, this is a loop, and the magnetic moment of this M1, let us write M1 ABC, for ABC M1, this will be I times area vector, and this is I. And what is area vector? The area of this loop is pi into capital R square. The magnitude of the area, this is a semicircle. So, it will be pi into R square divided by 2. So, it will be pi R square, this is the area of the full circle, and semicircle. So, it is divided by 2. And what is the direction? So, if you look at this arrow here, this is the x axis, from x axis point I am going this y axis point. So, if this is x, and this is y, I am going from a point on the x to the point on y, then the direction is is anti-clockwise and it will be up. So, if this is x, this is y, then k direction. So, this is in k cap direction, and this is of course y z plane. So, easy to see here, this semicircle M2 is equal to again you can call it IA1 and this will be IA2. This semicircle from here to here and then here to here closes. So, this current I have used for this one and this current I am using for this one, and this is I, a semicircle once again, the radius is small a. So, pi a square by 2 direction. So, if it's again anti-clockwise. So, this is coming towards me, this is y, this is z, x. So, it is I cap, and the net magnetic moment of this loop given is just sum of this. So, that m is equal to sum of these pi by 2 and I, and then you have a square I cap and plus this r square k cap. That is the magnetic moment of this given loop.